Hello, my name is Cassie Mencia, and this is my proposed restoration plan for Santa Rita Experimental Range in southern Arizona. Santa Rita is located 35 miles south of Tucson, Arizona, in Pima County at the foothills of the Santa Rita Mountains. It ranges in elevation from 2,900 to 5,200 feet above sea level and spans a total of 53,159 acres. The mission of Santa Rita is to conduct long-term ecological research in support of livestock production and range management in the arid Southwest. There is one large herd of roughly 400 cattle rotated through 21 pastures and one small herd of 80 cattle rotated through 11 pastures. Current grazing strategies are to prevent regrazing of plants in the summer by only grazing for 10 days max during the season and to subsequently assess dormant season grazing capacity based on summer forage production. Santa Rita was founded in 1902 and is currently managed by the University of Arizona College of Agriculture. Santa Rita has provided a reliable landscape for experimentation, education, and outreach, and in doing so has contributed to hundreds of scientific publications, as well as recorded notable changes in the landscape over the last 122 years. An example of this is their repeat photography protocol conducted throughout the range, as shown in this slide. Aside from research, the majority of Santa Rita is open to the public for recreation such as hiking, camping, birding, off-roading, and hunting select game species. Santa Rita consists of semi-desert grass shrub vegetation varying in composition from sloping alluvial fans to steep foothills cut by arroyos and canyons that can become quite forested as seen in the bottom right photo in Florida Canyon. Variation in soil composition and increased precipitation with increasing elevation contribute to vegetation composition throughout the range. Southern Arizona experiences bimodal precipitation with widespread light rains and snows in the winter and heavy isolated or scattered lightning storms known as monsoons in the summer. Depending on the amount of precipitation, this typically contributes to two peak grains of vegetation each year, one in the spring and one in the fall. Santa Rita is extremely diverse. A full inventory completed by Alvin Medina in 2003 recorded 468 species of vascular plants. Common native grasses include many bunch grasses such as black grama, 3-awns, and Arizona cottontop, among many others. Additionally, the invasive Lehman's lovegrass is dominant throughout much of the range. Common forbs include lupin species, poppies, and pink penstemon, among many. Common cacti include saguaro, prickly pear, barrel cacti, pincushion cacti, and several choice species. The most common woody species include creosote, velvet mesquite, ocotillo, and yellow palo verde. Wildlife of Santa Rita includes many snakes such as rattlesnakes and the Sonoran gopher snake, birds such as the cactus wren and Gambel's quails, and many mammals such as kangaroo rats, coyotes, javelina, deer, white-nosed coatimundi, and of course the exotic cow. Unfortunately, not all areas of the range are beautifully diverse. Lehman's lovegrass was first purposefully planted in Santa Rita in 1937 to assess its adaptability to varying soil and precipitation conditions at different elevations and to test for forage suitability in arid systems. Researchers soon learned that although the lovegrass is very sturdy and resilient to disturbances such as heavy grazing, fire, and drought, this allowed the lovegrass to dominate over native grasses. Additionally, Lehman's lovegrass is less palatable, with cattle preferring to eat native grasses first. Many parts of the range understory are now covered in seas of matured Lehman's lovegrass as shown in the picture above. Areas dominated with Lehman's lovegrass provide plenty of fuel for wildfires, especially during long periods of drought, ultimately altering the fire regime. A notable recent fire that occurred at Santa Rita was the Sawmill Fire in 2017. It was unintentionally started during a gender reveal event involving firearms. Here is the footage of the incident posted by the U.S. Forest Service. Although human negligence was a huge factor here, the dense stands of mature Lehman's lovegrass provided enough fuel for the wildfire to burn a total of 45,000 acres across multiple land agencies and an estimated loss of $8 million. The goal of this project is to restore important functional groups, including native grasses, to Santa Rita by eliminating the threat that invasive Lehman's lovegrass has created by outcompeting the native grasses and increasing the risk of wildfire. Additionally, it is a goal of this project to do this without impeding on the ongoing mission of Santa Rita. This means goals of this project must be worked towards without altering the ongoing grazing schedule. Restorative efforts of this project ultimately aim to be integrated into the long-term ecological research of Santa Rita and promote self-sustainability and resiliency of the overall health and integrity of the rangeland through continuous monitoring and applying adaptive management practices. The following protocol for reducing Lehman's Love grass stems from recommendations made by Bedenbender et al. 1995. Multiple treatment methods on Lehman's Love grass should be conducted over a minimum of 2 years. On the first year, treatment will begin in the winter using a controlled burn on invaded pastures. Timing of burn should work around the winter grazing schedule to allow cattle to utilize available forage prior to the burn. This will rid the leftover stand of matured Lehman's lovegrass and reduce the risk of fire while also forcing the available Lehman's lovegrass seed banks and soil to grow in the spring. Once spring arrives, new growth of Lehman's lovegrass will be treated either with a mow in high density pastures lacking native vegetation or a glyphosate spot treatment to work around native vegetation. In early June, the treated pastures are to be reseeded using a mix of native grasses and spring forbs. In late August, pastures are to be reseeded again using a mix of native grasses and fall annual forbs. The second year of treatment will exclude a winter burn and begin by repeating the previously mentioned spring mow and/or glyphosate spot treatment followed by native vegetation reseeding in June and late August. Successful sprouting of native seeds after reseeding are dependent on the amount of precipitation received during winter and summer seasons. If the range receives lower than average precipitation during a season, then the subsequent reseeding may be skipped. Additionally, if the range receives higher than average summer precipitation, then a third glyphosate spot treatment should be considered in the fall to counter opportunistic growth of Lehman's lovegrass. Seeds are to be sourced locally from around the range or relatively within the Tucson area to maximize successful revegetation and avoid the risk of introducing undesirable traits into the local plant community. Efforts for monitoring reinvasions of Lehman's lovegrass can be relatively passive and integrated from the data already being collected by multiple agencies. The Arizona Experiment Station, ran by the University of Arizona, currently measures vegetation cover and density of annual and perennial grasses, shrubs, and cacti of 131 permanent 1 by 100 feet transects throughout the range. These transects are revisited every 3 years. The figure summarizes the percent coverage of native perennial grasses to Lehman's lovegrass from 1971 to 2021 of 100 transects. After implementing the previously mentioned restoration protocols, data from the Arizona Experiment Station collected on these transects could be used to adapt retreatment plans as needed to combat new invasions of Lehman's lovegrass, particularly after a 3-year period from completing a treatment of invaded Lehman's lovegrass pasture. If the percent coverage of Lehman's lovegrass is 1% higher than the native perennial grasses or more along the transect, then a plan should be made to reconduct another full treatment cycle. If percent coverage of Lehman's lovegrass is 0 to 0.99% higher than the coverage of the native perennial grasses, then an as needed treatment plan can be adapted, such as treating small problem areas with glyphosate during early spring and only reseeding once during early June. Notably, another agency called the National Ecological Observatory Network, or NEON, also assesses percent coverage of plants in 1 by 1 meter squared subplots within 48 40 by 40 meter plots scattered across Santa Rita, while conducting their plant diversity protocol twice each year. Data collected by NEON could also be used to monitor reinvasion of Lehman's lovegrass in pastures in the same fashion as the transects, but on a more frequent scale if needed. Here is a detailed list of references used throughout the slideshow for this restoration project. Thank you for listening, and I hope you enjoyed my restoration plan for Santa Rita Experimental Range.